All right, let's talk about a topic that seems to give everyone a headache. Speed, distance, and time. You know the ones, those word problems about trains and boats that feel like they're designed to make your brain just freeze up. Well, today we're going to unpack all of that. I'm going to show you how to look at these not as impossible riddles, but as puzzles that you absolutely have the tools to solve.
Seriously, have you ever been there? Staring at a question about two trains heading towards each other, or a boat struggling against a current, and you just think, there's no way. It feels like they're intentionally trying to trip you up. But here's the thing, they're not as scary as they look. I promise you, by the end of this, you'll have a clear, simple toolkit to just knock these problems out, no sweat.
So, here's our game plan for today. We're going to start with the absolute bedrock, the core relationship of it all. Then we'll get into what I call the universal translator for units. From there, we'll tackle how to figure out average speed and then the really cool concept of relative speed. And once we have all that, we'll use it to finally solve those classic problems and wrap it all up with a problem-solving toolkit you can take with you anywhere.
Okay, let's start at the very, very beginning. Because everything else we talk about today, every single formula, every tricky problem, it all builds on one simple fundamental relationship. If you can get this, really get it, the rest is going to click right into place.
First things first, let's make sure we're all speaking the same language. It really just comes down to three questions. Speed is all about how fast. It's the rate you're moving. Distance is how far, the total ground you covered. And time is how long it took you to do it. How fast, how far, how long. That's our trio.
And here is the one formula to rule them all. Distance equals speed multiplied by time. This is the unbreakable link between those three ideas. And the best part? If you know this one, you basically know all three. Because if you need to find the speed, you just rearrange the formula. Speed is just distance divided by time. And if you need to find the time, you guessed it. Time is just distance divided by speed. Every single problem starts right here.
All right, before we dive into solving problems, we need to talk about a critical step that you cannot, and I mean cannot, skip. We need a universal translator for our units, because these problems love to give you numbers that don't quite match up.
And why does this matter so much? Well, think about it. If you have a train speed in kilometers per hour, but the length of a bridge is given in meters, you can't just plug those numbers into our nice, neat formula. The math will just fall apart. All your pieces, your distance, your time, they all have to be speaking the same language for the equation to work.
The good news is you really only need to get comfortable with two main conversions, going from kilometers per hour to meters per second, and then going back the other way. It sounds a little complicated, but it all comes down to one little trick. Just burn this one fraction into your brain, 5/18. That is your magic number. To change kilometers per hour into meters per second, you just multiply by 5/18. Now, where does that come from? It's actually simple. There are 1,000 meters in a kilometer, right? And 3,600 seconds in an hour. So you have 1,000 divided by 3,600, and if you simplify that fraction, you get 5/18. It's not magic, it's just math. And to go the other way, from meters per second back to kilometers per hour, you just flip it upside down and multiply by 18/5.
Okay, let's move on to our first real-world application, figuring out average speed. Now, on the surface, this sounds super easy. But there's a really common trap here that a lot of people fall into. It's almost never as simple as just adding two speeds together and dividing by 2.
Let me give you an example. Let's say you drive to the store at a slow 30 kilometers per hour. Then, on the way back, the road is clear and you zip along at 60 kilometers per hour. Now, your gut instinct, your brain's first reaction, is probably to just average 30 and 60 to get 45, right? But that's wrong. So why? Think about it. You spent a lot more time driving at that slower speed.
The secret is knowing which situation you're in. See, for our car problem, the distance to the store and the distance back was the same. When the distances are equal, you have to use this special formula, 2xy over x plus y. So for us, that's 2 times 30 times 60 divided by 30 plus 60. And that gives you 40 kilometers per hour. The simple average, just adding and dividing by 2, That only works in the rare case where you travel for the exact same amount of time at each speed.
Now we get to a really cool, kind of mind-bending concept that makes problems with more than one moving object so much easier. It's called relative speed, and it's all about changing your point of view, your frame of reference.
Just think about it for a second. If you're sitting on a fast-moving train, how fast are you moving? Well, relative to your seat, you're not moving at all. But relative to a person standing on the ground outside, you're moving at, say, 100 kilometers an hour. That's the core idea. As the source material puts it, speed only makes sense when you describe it in relation to something else. And by cleverly picking our frame of reference, we can make complex problems simple.
And here's the simple rule. When two things are moving in opposite directions, either coming right at each other or moving away from each other, the space between them is changing really fast. So, to get their relative speed, you add their speeds together. But if they're moving in the same direction, like one car chasing another, you want to find the difference in their speeds. So you subtract the slower one from the faster one.
Okay, it's go time. We've got our core formula. We've got our unit translator. We understand average speed and relative speed. Let's put all these tools together and finally slay those monsters, the train and boat problems.
All right, here's a classic. You've got a train that's 360 meters long. We're told it takes 12 seconds to pass a stationary pole. Okay, so the question is, how long will it take that same train to completely pass a platform that's 900 meters long?
Let's walk through it step by step. Step 1, what is the total distance the train needs to travel? Now this is key. To completely pass the platform, the front of the train has to travel the entire 900 meters of the platform, and then the rest of the train has to clear it too. So we have to add their lengths together. 360 plus 900 gives us 1,260 meters. Step 2, let's find the train speed. We know it covers its own length, 360 meters, in 12 seconds when passing that pole. So speed is distance over time. 360 divided by 12 is 30 meters per second. Easy enough. And now the final step. Time equals total distance divided by speed. 1,260 meters divided by our speed of 30 meters per second, and we get our answer, 42 seconds.
Now let's switch gears to boats and streams. Don't worry, the logic is exactly the same as what we just did. We're just swapping one moving object for a flowing river current. The only thing you need to ask yourself here is the current helping me or is it hurting me?
And it's really intuitive. When your boat is moving with the current, we call that downstream. The river is giving you a push. So your actual speed over the ground is your boat's speed plus the stream speed. But when you're going against the current, or upstream, you're fighting it. So your effective speed is your boat's speed minus the stream speed. It's just another version of relative speed.
Whew! We have covered a lot of ground today. So before we wrap up, let's just consolidate everything we've learned into your new, shiny problem-solving toolkit.
Here it is, your 5-point mental checklist for any motion problem. 1. Always start with the core formula. Distance equals speed times time. 2. Be the translator. Make sure all your units are speaking the same language before you do anything else. 3. When you see average speed, watch out for the trap. Check if it's an equal distance or an equal time problem. 4. If you've got more than one moving object, think relative speed. Add for opposite directions, subtract for the same. And finally, 5. For those train problems, always remember to add the links to get your total distance.
So there you have it, a really powerful framework for solving any problem that deals with constant speed. But that brings up a really interesting question, doesn't it? We've mastered this clean, perfect world. But what about the real world? What happens when things don't stay at a constant speed? When they start to speed up or slow down? Well, that's a whole new puzzle, and that's a story for another day.